Hey guys, just as a quick primer to Grasshopper, let's discuss a little bit about whether you can use it or should you use it before we get into, should we be learning it for you. For myself, from a technical point of view, and for mass production, yes, it makes sense, but I'm not entirely convinced that for the majority of the designers it's of any use. So let's look at how we create an ordinary object in Rhino versus creating something in Rhino, and then what the benefits are. So in Rhino we would create a circle from F4 to whatever size our ring was going to be. For example, that was the size of it. It had to be, 1.7 mil thick. Okay, and it had to have a certain width. So at this point we would extrude our ring. Make sure cap is on, and we would extrude our ring, 6mm wide, so make it 3 either side. And so then in Rhino we've got this ring made. It's now complete. The job is done. If all you needed was that ring, then this would be a very fast workflow, and there would be no reason for you to look at Grasshopper. So let me show you the same way that ring is built in Grasshopper, and the reason why that's of more use to us in an ongoing method. Alright, so I'm going to delete that, and we're going to invoke Grasshopper by typing Grasshopper. Of course, this will only work if you've got Grasshopper installed on your machine, and this is just a very rudimentary example. Alright, so what Grasshopper will do, it will open a new window. It's going to be difficult for me to record on a small screen like this, but I'm going to go File and create a new document. Okay, so the same elements we used in Rhino we're going to use in this. We're going to be using a circle, an offset amount, an extrusion amount. Apologies helping young Tracy there. So we got the same parameters in Rhino. We have a initial finger size. So I'm going to double click here. I'm going to just put in a number to let it know we'll be working with a number in this radio box. I'm going to put in 16mm because that's around about size N or something, right? So we've got a slider over here that we can now change a number on. Alright, I did that again by just double clicking the bottom. So we're going to have that. Then we're going to have the thickness of the ring, which is going to be in the range 0 to 5mm assumedly. So I'm going to put in 2mm in this number slider. Alright, I'm going to stick it over there, and then we're going to have a width of a ring, alright, which is going to be maybe 4 or 5mm. I don't know, let's put in 4. Remembering, of course, that this slider can be changed at any time. So I'm going to customize the slider now by double clicking it. I'm going to give it its name, ring size. Okay, I'm going to customize this one and call it thickness. Okay, and I'm going to call this one width. Okay, so we've got these 3 sliders over here that we can start using to build our object. Okay, I'm going to see if I can start moving this a little bit smaller and try to work in a view somewhere. Right, so the first thing we want to start doing is create a circle. Alright, so double click and look for the command circle. Circle, 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 center with a normal and a radius. So there's the little pop-up guy over there. It's saying, what is my input? I need a center point. It's asking what is the normal, in other words, in which plane are we drawing in, and what is the radius. So the center point is easy. I'm going to right click this. I'm going to go down to set one point. I'm going to go into this view, and I'm going to press F4, which those of you with matrix would know is center of world origin. Of course, if you wanted this to be fully parametric, you could have it tied to a point which asks the user for input. But anyway, to keep this simple, we're going to say that we've now set that value to the center of the world. The normal is set one vector. It's saying which plane are we drawing? The circle is going to be in this plane. That's up. Okay? And then a radius. So at the moment we have a ring size radius going into there. Alright, so we've made our first grasshopper. So if we look at, let's open this so it's out of our way, you'll now see that as you move this, you have a circle that has variable size. Okay? So the thickness is going to be another circle, because we need another circle that extends past by the thickness of the ring. So you have another circle. Okay. its center. It's going to be the same center as this. F4. Its normal. It's going to be the same as this. Set one vector. Oops, I need to get out of this view. Like that. And now its radius is going to be this thickness, but this thickness is going to be equal to this thickness plus that thickness. Alright. So we're going to create an addition. So A plus B is going to be the new radius. Alright, so now we're now going to take a feed from the ring size, pop it into there, take a feed from the thickness, pop it into there, and pop this in as the new radius. Alright, so what this means is as we change the ring size, let's open this up, we now have, when you scale it bigger and smaller, the distance between the two stays the same, no matter how you change your ring size. Okay, and if you change the thickness, moving up and down, it will stay the same again. Of course, remember you can change this to a real number, which means that you can now have down to 1,000th of a millimeter the correct thickness. Okay, and this will just keep adding it like so. Right. So the last thing we need to do is turn this into a ring, as per our last example. Right, so I'm going to zoom back a little bit, and we're now going to start extruding, capping, and booleaning something, which is what happens in the background of our extrude command. Right. So we're going to extrude curves along a vector. Alright, so we're going to grab this curve as our input curve. We need a vector. We need to extrude this in Z, so the vector is going to be Z. So we're going to take this 4, we're going to pop it in here, we're going to pop that in there in the direction. So you can see what it's done. It's now extruded that by the distance of 4. Try and move that so that it makes sense for you to look at it. And we're going to do the same thing again. Control C, Control V. Let's put this one down here. But you are going to have a new vector, Z. Again, it's from this same feed into that direction. Okay. Oopsie. And you're going to come from there. So what we've done, we built this first circle. Alright, let's try and move this so it makes sense for you. And we've said that we want to extrude it by 4 along the Z plane, and we've extruded it. Now we've done the same thing for this bottom one. The bottom one, we've just added a little bit of math inside there to say that the bottom one must always stay relevant to the first one by the factor 2.040. Right. So now the last thing is to turn it into a ring. We now need to create a difference. We need to cap, apologies. So we need to cap holes. So we need to cap this. We need to do another cap. So the same commands as you run in Rhino. Okay. So we need to cap this, and then we need to do a Boolean difference. Now which one is which one? You can see that that's your outside one, and that's your inside one. So we want a solid difference. It's a solid, and we want to do a difference with it. So it's showing you it's A is what's left over after being cut away with B. So this is our A. It's the outside. Okay, and we want to cut B away from it. Okay. Now at the moment there's a lot of confusing stuff on the table because each and every single step has been shown. So let's hide the steps we don't want to see. Highlight all of those. Press space and put on the little mask on the guy. Alright? So those are now hidden. They're shown, the icon is now grey. Instead what you see in your screen, and the shading is very low, let me turn the shading up. Alright, so instead what you see in your screen is you now have this final step, which is the difference between them. And in so doing, you now have a ring where you can change your ring size, the width of the ring, and the thickness of the ring quite easily. Right? So this means that once you've drawn a ring once like this, there's infinitesimal number of ways that you can alter this ring. For example, if you wanted to know what this weighed in 10 different sizes and 5 different widths and 20 different thicknesses, instead of having to draw each and every one of those rings and then weigh it, you can just come in here and ring size 19, it's this 20, it's that 24, it's that 25. Each time I've already written one that pops your weights out on the side. Okay, so that's a little explanation of how Grasshopper works. Once you're complete and you have the item you want, you can just what's called baking, that you can bake the item. Okay, and what that will leave you with if I exit grasshopper, I'm not going to save that, it's very rudimentary. What that will leave you with is a normal Rhino object in your screen that you can then continue to work with in Matrix or anywhere else. Alright, so I hope this explained grasshopper a little bit, and the team can get an idea whether they think it's worth learning it or not. Cheers, Chris out.